We are going to do optimization problems. The goal here is to find some function that you want to optimize that's in terms of just one variable. Then you take your derivative, set it equal to 0, and find the critical values. So suppose you have the function y equals 4 minus x squared. Now, the point 0, 2 is not on that curve, but I want to find the shortest distance. I want to find which points are the shortest distance away from 0, 2. Which points on the graph. So, visually speaking, x squared is an upside down U shape at the origin, but this is negative x squared plus 4. So it goes up 4. This is the graph. And here is this, and let's just be a little bit clearer. That point is 0, 4. And here's the point 0, 2. And I want to know which points on that curve are closest to 0, 2. Now, due to symmetry, if it's this point, well, then it's also going to be that point. The only way they won't come in pairs is if that point right there is the min distance. It's the closest point on the curve to the point 0, 2. Other than that, it's going to occur in pairs. So that's 0, 2. So what you do is you pick any arbitrary point on the curve. Call it xy. And let's find the distance. Well, the distance is between those 2 points is the square root. You subtract the x values and you square it, plus you subtract the y values and you square it. Now, the first thing I'm going to say is that when it comes to square roots, this here is the function. It's always increasing. That is, if you take the square root of this number, you'll get that height. And if you take the square root of a larger number, you get a larger answer. If we just found out, and we want to minimize d, if we found out the least that can be, like suppose the least that can be is 9, then the least d can be will be the square root of 9. It's never gonna be that if the least this can be is 9, that the d, including the square root, can ever be more than 3, the square root of 9. So why don't we just define a new function? Let's call it d star, and d star is just x minus 0 squared plus y minus 2 squared, and we want to minimize this function. But as I said before, you want to find the function that you can minimize, but it needs to be in terms of one variable. Well, clearly that has 2 variables. But we have a way of getting rid of y. I can replace it with 4 minus x squared. So d star is x minus 0, which is x squared, plus y, 4 minus x squared, minus 2, all squared. Well, 4 minus 2 is 2 minus x squared, all squared. Now, I have the function that I want to minimize in terms of one variable. So now we take the derivative. The derivative of d star is, well, x squared. The derivative is 2x plus. Here we have a function to a power. Well, we bring down the power, make the new power 1 less, and then we multiply by the derivative of what's inside there, which is negative 2x. So we have 2x, and positive 2 times negative 2x, why that's negative 4x, times the last factor. Now, if you FOIL this out, you will get the negative 4x, that is, you'd get negative 8x plus 4x squared. I'll write the 4x squared first, and 2 minus 8 is negative 6x. And we want to set the first derivative equal to 0. Now, I can factor out a 2x, and then I get 2x minus 3. So what's bothering me? When I multiply that, I should get 4x cubed. I should get 4x cubed. So when I factor out 2x, I'll get 2x squared minus 3. Now, when is this 0? Well, 2 is never 0, but x can be 0. And when is 2x squared minus 3 equal to 0? Well, that better be 3. I don't care what it looks like. Only 3 minus 3 is 0. So 2x squared must be 3. So that means x squared must be 3 over 2. Because only 2 times 3 over 2 gives me 3. So x squared must be 3 over 2. So x must be plus or minus the square root of 3 over 2. Okay. So those are our two critical points. We want to know which one's a min, which is, okay, so the numbers in order are, the smallest is negative the square root of 3 halves, 0, and positive the square root of 3 halves. So when it comes to our number line, we go from negative infinity to the smallest value, and then from the smallest, from the smallest value to the next value. Then we go from 0 to the next value. And as you see, I ran out of space. So let me just lower that. Let me go a little bit lower. And then the last one is, the last interval is going to be from the square root of 3 over 2 to positive infinity. And we want to look at the sign of the first derivative. We want to look at the first derivative. When is it positive? When is it negative? In these intervals. Well, what is the first derivative? That would be nice to know. Well, this right here is the first derivative. It's 2x squared, it's 2x times 2x squared minus 3. Now, I think it'll be good to factor out another 2. That 2. So we'll have 4x times x squared minus 3 over 2. Now, this here is the difference of squares. This is x squared minus the square root of 3 halves squared. So I can factor that. It's going to be x minus the square root of 3 halves times x plus the square root of 3 halves. And, well, I guess we have the derivative right there. Okay, let me just try one thing, please. Okay, let's get rid of this. the derivative in factored form. Factored form is really the best. The derivative equals that. And let us bring up the beginning of our table. Well, I guess we're not going to have room. I tried. Okay, so we have our derivative in front of us. Let us make these intervals. Now, 4, this is a product of 4 factors, the derivative. And 4 is always positive. X is only positive if we're bigger than x, to the right of that. It's negative otherwise. This is positive if x is bigger than the square root of 3 over 2. But that only happens here. So it's positive there and negative elsewhere. When is x plus radical 3 over 2 bigger than 0? Bring that to the other side, and you'll learn that is when x is bigger than the radical, negative the radical of 3/2. Okay, it's to the right of that spot. Okay, so it is positive, oh, that should be negative. It's positive, 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 and then negative. This has 3 negatives, so it's negative. This has 2 negatives, so it's positive. 1 negative, so it's negative, and then positive. It's decreasing, and then it increases, and then it decreases, and then it increases. So we have mins here. Where is here? Just go up and look. It's at negative square root of 3/2. Where's the min over here? Just go up and look. It's at positive the square root of 3/2. So now I know my answer. It's going to be when x is negative radical 3/2 and when x is positive radical 3/2. But what is the y value? Well, y is 4 minus. I can sneak in both of these numbers, plus and minus, because when we square it, we get 3/2. This is 8/2. Take away 3/2 is 5/2. Okay, so I found the 2 points. Again, it's this point and that point. Now, what if I wanted to find the min distance? Okay, let me erase an awful lot here. Well, I have what d star is. All I have to do to get d is take the square root of d star. Well, x squared, regardless of which one we use, we get 3/2 plus 2 minus x squared. Again, we get 3/2, and that gets squared. So we have 3/2 plus, this here is 4/2, minus 3/2 is 1/2. And you have to square it. Okay, we're getting there. The first number is 6 over 4. Plus a 1/2 squared is the quarter. That's why I wrote 3/2 is 6 over 4. And when I add them, I get 7 over 4. So the final answer is square root of 7 over 2. That is the shortest distance between this point and any point on the curve is the square root of 7 over 2. That's that distance, and it's that distance. Okay. It's a long problem, but you have to be able to do it. Now, let us try the next problem. Suppose you have 600 feet of fencing. And maybe you want to build a dog pen with the 600 feet of fencing. But here's the situation. You have this structure, and you're gonna build the dog pen like this. That is, you don't have to put any fencing around the wall. Now, I want to draw this just slightly differently. Let's not worry at all about the length that it can be. The wall's as big as possible, and you have 600 feet of fencing. Now, you want to maximize the area. So you're only going to put fencing along three sides. One side, two sides, and three sides. Now, I want to motivate this problem. So here is your wall, and you're going to put the fencing along here. And you have 600 feet of fencing. Well, you can put 1 foot here and 1 foot here. That use 2 feet. So you're going to put 598 feet there. And this area is going to be 598 times 1 foot, which would be 598 square feet. Or maybe you can put 5 feet here, and of course 5 feet there. That used up 10 feet. So from there, you have 590 feet left over. So what is the area? The area is side times side. 59 times 5 is 295. 2950. This is around 600. This is around 3,000. This is 5 times bigger. Almost. But it's for the same perimeter. That's bizarre. What if, or is it? What if you put 200 feet here and 200 feet there? That's 400 feet. So obviously, from 600, you have 200 feet remaining. Well, this area is going to be 200 by 200, which is 40,000 square feet. 40,000 square feet. Way bigger than less than 1,000. Way bigger than just under 3,000. And you know what? It's the same 600 feet. This is a very serious problem that one should know how to do. Because, for example, if you really do have 600 feet of fencing, or 200 or 70 feet, and you want to build the dog pen and you want to put it along the wall, one of your walls, which means you don't have to put any fencing along one side of the wall, and the wall's as big as you want. It's at least 600 feet, okay? It's at least 600 feet. So as long as you put less than 600, you're okay. And you're never going to put more than 600 because you only have 600. Wouldn't you rather give the dog 40,000 square feet to have versus 600 square feet versus around 3,000? So the question is very real. What should the dimensions be? Okay. So you want to maximize this area given that you have 600 feet of fencing. Well, Suppose I put x feet here. Of course, I put x feet there, and I put y feet there. So the area is going to be like always. It's going to be side times side. It's going to be x times y times foot times foot. X times y times foot is xy square feet. The problem is, so now you want to maximize this. Problem is that it has two variables. Well, let's use this fact. The perimeter right now is x plus y. I have x feet here, x feet here. Well, that's 2x plus y. And this has to be 600. So it's easier to bring that over because then it just says y equals. Y is 600, minus 2x. If you brought, well, let me just write this. 600 minus 2x. If you brought the y over, then you'd have 2x is 600 minus y, and then you'd have to divide by 2 to get x. But I didn't have to divide by anything to get y. So now we're done almost. A is x times y. But that's y. And this is 600x minus 2x squared. But if you're clever, this is a negative parabola. It's only going to have a max. Okay, so we take the derivative, which is 600 minus 4x, and we set it equal to 0. So that must be 600. 600 minus 600 is 0. So 4x's are 600. Divide by 4. You learned that x is 150 feet. Okay. So the question is, let's say maximize the area. So x is 150, and we know that y is 600 minus 2x. So it's 600 minus, well, 2 150s are 300. So y is 300 feet. Okay. Now the area we always said was length times width, which is 150 feet times 300 feet. 150 feet times 300 feet. Well, 15 times 3 is 45 with 1, 2, 3 zeros. 1, 2, 3. Foot times foot. So you can get the max area is 45,000 square feet. And how do you do that? Well, you let y be 300 feet and x be 150 feet. Okay, just want to see. Oh, I guess I erased it. Oh, I went on this page. So, in my example here with 200 feet on each side, we only got 40,000 square feet. But the max area is actually 45,000. That is so much bigger than a little under 3,000. It's 15 times smaller. Forget about this. Your dog's going to laugh at you, or your neighbors are going to laugh at you, because whether you bought the fencing or not. See, if you go to buy the fencing, you can't say, well, you know what, my friend down the street, he bought 400 feet of fencing and he built a dog pen that had 45,000 square feet. Me, I'm only gonna build a dog pen 598 square feet. And you know, he paid $1,000 for that. And you're telling me that I also have to pay $1,000. That's ridiculous. He's getting, you know, what was it, 50? No, not even 2. He's getting way more area than I am. So, you know, I only think I should pay 200. They're going to throw you out of the store. Why? Because 600 feet times, I don't know what fencing costs, but maybe it's $1.50 per foot, and it's not 1,000, but it's rather $900. They don't care once you leave what you do with your 600 feet of fencing. You can go to the garbage can right in front of the fencing store and throw it out. You can build your dog pen using just 3 sides that have 598 square feet, 2,950 feet, 45,000 square feet. They don't care. They want their $900. The point I'm getting at is, why not maximize the area? Now, I'm going to show you how you can do such a problem really simple. You have, or get the answers real simple. Really simple. So, you're going to build something like this. You know, you have this wall here. So, you're only going to put fencing here, here, and here. Now, 600 feet. 300 of them are going to go for vertical, and the other 300 feet, they're going to be used for horizontal fencing. Come on. 300 feet. This is horizontal. 300 feet vertical. And you have 600 feet. So the vertical, the ones that go up and down, you have 300 feet. Well, you need 2 pieces to go vertically. So half of 300 is 150. To go horizontal, you have 300 feet of fencing. Oh, you only have 1 horizontal piece, so put it all horizontally. And there's your answer. Suppose, on the other hand, you want to build a dog pen like this. Maybe you have 2 dogs, so you want to separate them. Okay? And let's stay with this. Let's go with, give me a second, what's bothering me? I don't know. Let's say you have 1,200 square feet. So it becomes 600 feet vertically and 600 feet horizontally. Well, how many pieces are you putting vertically? Well, you're putting 1, 2, 3. Divide this by 3. So they're each gonna be 200 feet long. They're each gonna be 200 feet long. For horizontal, you have just 2 pieces. 1 piece, 2 pieces. So you divide it by 2, and you get 300 feet each. That's gonna give you the maximum area. It's gonna be 300 feet by 200 feet. 3 times 2 is 6. 4 zeros in total. Times foot times foot. You can get an area of 60,000 square feet. And that's the most you can get. Let me just do one example. Another example. Suppose you're going to configure it this way. You need to partition that 4 and 3. And suppose you have 2,400 feet of fencing. Well, 1,200 feet, that's going to be for horizontal, And the other 1,200 feet, that would be for vertical. Well, how many horizontals do we have? 1, 2, 3, 4. Divide by 4, you get 300 feet. It's going to be 300 feet long. Vertically, 1, 2, 3, 4, and I didn't mean this, but 5. You divide this by 5, you get 240 feet. So it's going to be by 240 feet. That is the largest area you can get. Unfortunately, on an exam, you probably can't do this. You have to show your work. But fairly easily, you divide this by 2. 1,200 goes horizontally. 1,200 goes vertically. And then you decide how many horizontals you have. 1, 2, 3, 4. Divided by 4, 300 feet. Divided by 5, 205, because we have 1, 2, 3, 4, 5 going vertically. 240 feet. Now do the calculus and you'll get the same answer. Okay, and if you don't, and you didn't make a mistake here, go back and find your error. Okay, so that's pretty neat. Now, let's do a few more problems. Suppose you have the curve y is equal to the square root of 8 minus x squared. Now notice, if you square both sides, you get this, and if you bring this to the other side, you get x squared plus y squared equal 8. Don't know why it does that, but that's what you get, and it's a circle. X squared plus y squared equal 8 is a circle. Now, what's going on here is that if you go from this circle to this circle by just bringing the x squared over, you'll get this. And then if you take the square root of both sides, you'll get that y is equal to plus or minus of 8 minus x squared. Now, one of them, the plus, that will be the top half of the circle. And the minus will be the bottom half of the circle. So we just have the top half of the circle. And you should know that from pre-calculus, that graph y equals the square root of 8 minus x squared is a circle. So you have this. Y is equal to the square root of 8 minus x squared. Now, you may want to know, well, what is the radius of the circle? You may not need it, but one might want to know. So remember, this is y squared is equal to 8 minus x squared. Bring the x squared over. This equals 8. But that's the square root of 8 squared. So the radius is the square root of 8, which is the square root of 4 times the square root of 2. And I know the square root of 4, and I don't know the square root of 2. That is, in case you were wondering, this is 2 radical 2, and the other one is minus 2 radical 2. Why is that? Because that's the center of the circle, and that's the radius. That must be 2 square root of 2. All right. The question is, what is the largest rectangle you could inscribe in here? So, how is a rectangle defined? how is a rectangle defined? Well, you can define a rectangle just by that point, because then you know this point. This is negative x comma y. And you know this point. X is negative x and the y value is 0. And you know this point. X is x and y is 0. Okay, so knowing that point in quadrant 1, that's enough to define the rectangle. Now, what is the area of this rectangle? Well, the base is 2x, because this is x and that's also x. The base is 2x. What is the height? It's y. It goes from 0 to y. The height is y. Okay, so we have A and we want to maximize it. So it's looking good until you realize that, oh my, I have two variables, x and y. I need to get rid of one. And this was kind of side work, so ignore that. You look around and you say, oh, that's another way of writing y. So A is 2x times 8 minus x squared. Now, we want to take the derivative of this and set it equal to 0. So it's probably best to think of that square root as this. And we have a product. It's this times that. So let us use the product rule when we take the derivative. A prime is the derivative of the first, which is 2, times the second. I'll write the square root sign. Plus just the first, which is 2x, times the derivative of this. Well, if you have 8 minus x squared to a power, you bring down the power, you make the new power 1 less, and don't dare forget to take the derivative of what's inside, which is negative 2x. Now, these 2's cancel. So you have 2 radical 8 minus x squared minus 2x times positive x is minus 2x squared times this. But since it's a negative exponent, I can put it in the denominator like that. Okay, now I want to, so this is a prime, and I want to set this equal to 0. Well, let's write that. If you subtract two quantities, personally, that's negative a half, and when it goes into the denominator, it'll become positive a half, which is square root. If you subtract two quantities and you get equal to 0, as quickly as can be, you should say that those two quantities are equal to one another. They are equal to one another. Now, if I multiply this denominator times the other side, I'll get the numerator. So it's 2 times this times that, which is just 8 minus x squared. And that equals 2x squared. Distributing, we get 16 minus 2x squared equals 2x squared. Well, bring this to the other side, and you have 16 is equal to 4x squared. So that must be 4, only because 4 times 4 equals 16. So x squared equals 4. So x is plus or minus 2. Now, you can say, well, we defined x to be in quadrant 1, so x is 2. Okay, now, do you have a max or a min here? Let's look at from negative infinity to 2, and then from 2 to infinity. Now, if x thing that puzzles me is that both of these terms don't care if x is positive or negative. I want to see one thing. So, I mean, for example, we have a restriction on x. We have a restriction on x. So, we really can't go to negative infinity and positive infinity. We can only really go up to 2 square root of 2's, which, by the way, is the square root of 8. The reason I say that is because we want to square it. Okay, so let's write that down. Negative square root of 8 to 2, and then from 2 to the square root of 8. Now, zeros in this interval. If you plug in 0, you're going to get 2 times the square root of 8 minus 0 minus 0. So you're going to get a positive number. Now, if you take a number from here, like, well, this number is less than the square root of 9, which is less than 3. So it's between 2 and less than 3. You know, if this was given on an exam, you assume that it's doable. X equals 2. X equals 2 is a critical point. So if x equals 2, y is equal to the square root of 8 minus 2 squared is 4. It equals to the square root of 4, which is 2. That is, it's going to be 2, 2, and negative 2, 2. Okay, that is, the base is going to go from negative 2 to 2. So the base is 4, and the height is going up 2. So the largest area is 8 square units. Okay, the largest area that you can put in there is 8 square units. In other words, so here's the one we got, where we got 8 square inches. If you drew a wider rectangle, but not as high, you won't get as much of an area as the yellow one is. If you picked a fairly narrow one, but longer, you won't get as much as the yellow one. Okay? You won't get the most. So, for example, why might this be important? Okay? Let us suppose, now, and this, what I just drew as the axes is not part of the problem. You know what? So let's remove it. Suppose you have, suppose you have, I guess it's not a real life problem, because you can probably find a glass that's curved like this. But suppose you have an opening like this on one of your walls, and the hole is there. That's an opening. You can look out the house, you can look in the house, and you can seal up the cover, the opening. You can seal it in. Now, you decide that you want to put a window, a rectangular window. And might as well get the biggest window you can. And it turns out that we can use calculus to figure out where to put the window. Put the window there, and then you fill that in by any method that you like. Okay? But why not get the biggest window you can? These problems are real life problems. Okay, let us try a few more. There is something called a Norman window. A Norman window, it looks like a regular window, but then on the top you have a semicircle. You have a semicircle. And the perimeter is 16 feet. And the instructions are to maximize the area. In other words, you have 15 feet of, I don't know what to call it. So you can make it very narrow and have a small opening, a small semicircle, or you can make it very wide and have a semicircle on top, or you can go in the middle of those two extremes and have a semicircle on the top. And again, this is called, all of those are called a normal window. You know, for some reason that doesn't sound like the name anymore. Okay, but it's a special type of window. And all you have is 16 square feet. 16 feet, excuse me. And you want to maximize the area. Okay, so suppose we call this X feet and we call this Y feet. Well, what is the perimeter all the way around? Well, the perimeter is, well, it's that X feet, okay, X. It's that Y feet, okay, Y. And it's that Y feet, okay, another Y feet. But then as I said earlier, it's a Norman window, not normal. Okay, so now we want to know how much this is. Well, again, so let us just draw it a little bit differently. Let us draw this line. Now that line is not part of the Norman window, so it's not going to be part of the perimeter. Well, the thing is, if this is X feet, then this line here, which is now in blue, is X feet. But that means that the center to here, which is a radius, will be X over 2 feet. So we know that the radius is X over 2. Now, I don't want the circumference of a circle. I want the circumference of half a circle. And the formula for the circumference of the circle is 2 times pi times r. But I know r. It's X over 2. And this 2 and that 2 canceled out, so I get pi over 2x. That is this distance around. The radius is X over 2, and the circumference is 2 pi times the radius. But we're not, that would be the whole circle. So we divide by 2, and we get pi over 2x. Okay, plus pi over 2x. Now that's the perimeter, and we know that it equals to 16 feet. Okay? So now, what would the area be? What would the area be? Well, once again, let's include that line for a moment. This area here, it's a rectangle. It's going to be x times y, x feet times y feet. Now, what is the area of that top portion? What is the area up here? Well, the area of a circle is pi r squared. But, of course, we only have half a circle. Pi times r squared. Well, we talked about it. R is half of this. It is half of the whole thing. It's x over 2 squared. So we get pi times x squared over 4 over 2. That is pi x squared over 8. That is the area that we have to add on. This is the area of the rectangular portion plus the area of the circular portion. Okay. So that's the area we want to maximize. Might as well maximize it given that we can't have any leeway in the footage. We only have 16 feet of material to build a perimeter. Okay. Now, the problem here is, there we go again with this. We have two unknowns. Well, we have this perimeter equation. We have this equation right here. You have 2y plus, how many x's we have? We have 1 here, and we're adding on pi over 2 more. And this is equal to 16. So 2y is going to equal to 16 minus 1 plus pi over 2x. Dividing by 2, this will become 8 minus 1 plus pi over 2x over 2. Let us clean that up. This is 8 minus, let's get a common denominator. So we're going to have 2 plus pi over 2 times x. Well, that's 8 minus 2 plus pi over 4 times x. And let us keep hacking at this. Okay, actually, that's enough. That is what y equals. Okay, so bringing this equation over here, we want to maximize a equals to x times y, but y is this mess, plus pi x squared over 8. Now, I would definitely clean this up a little bit. We have this number times x, which is x squared, plus pi x squared over 8. And I notice we can clean up what's in there a little bit more. 2 over 2 is 1 plus pi over 2 x squared plus pi over 8x squared. Now, 8 minus 1 is 7 minus the pi over 2. That's x squared plus pi over 8x squared. So, we have x squares. We have this number of x squares plus that number of x squared. So, we have this plus that number of x squared. Just like if you had 3x squared plus 4x squared. you add the 3 and the 4. Usually you'll say 7, but you are adding the 3 and the 4, and then you multiply it by x squared. This is like the 3, and this is like the 4. Okay, that is A. Okay. So A prime. Okay, something looks wrong here. Give me a second. Okay, it seems like I really messed up over here. I know you're all screaming at me. Let's get rid of that. Anything below it? Now, what went wrong is that this whole thing is not being multiplied by x. Only that is. And one other typo. It's 2 plus pi over 4, and I had 2 plus pi over 2. Okay, so now we are in a much better position to get this right. So let us distribute the x in front. So we have 8x minus 2 plus pi over 4 times x squared plus pi x squared over 8. So this is 8 minus, now I'll combine the x squares. I like to have, actually in this case, let's have the plus. So I have pi over 8 x squares, and I'm taking away 2 plus pi over 4 x squares. And I want to set this equal to 0. Okay. Now, if I bring the 8 over to the other side, I have pi over 8 minus 2 plus pi over 4 times x squared. This is equal to negative 8. So I divide by that. So x squared is equal to negative 8 over pi over 8 minus 2 plus pi over 4. Now, let us multiply the bottom in particular by 8. So I have to multiply the top by 8. I want to clear out the denominators. So I get negative 64. 8 times that is pi, and 8 times this is going to be minus 2 times 2 plus pi. Okay, let us clean that up. It's negative 64 over pi minus 4 minus 2 pi. So it's negative 64 over negative 4 plus pi. The negatives cancel out. You get this. Pi plus 4. Or 4 plus pi. Okay, that is what x squared equals. So x is going to equal to the square root of 64 over the square root of 4 plus pi. Now, what did x represent? X was a length. How can x be negative? That is why I don't have plus minus. Okay, that is what x equals. What does y equal? Well, somewhere we had that y was equal to that. Y is equal to 8 minus 2 plus pi over 4, 2 plus pi over 4 times x. Okay? So y is equal to 8 minus 2 plus pi over 4 times 8 over the square root of 4 plus pi. 4 goes into 8 2 times, so you get 8 minus 2 times 2 plus pi over the square root of 4 plus pi. That is what y equals. Okay, so I found out the length, I found the dimensions, I found out what x is, I found out what y is. If you want to know the max area, oh, there's the formula. The max area, pi x squared over 8. Pi x squared over 8, x times y. The max area is, well, what's 8? X. 8 over the square root of 4 plus pi times y, which is 8 minus, I'm going to distribute the 2. 4 plus 2 pi over this plus pi over 8 times x squared. 8 over 4 plus pi square root squared. Okay, let us clean this up a little bit. Distributing there, we get 64 over the square root of 4 plus pi minus, when we distribute that, remember there was a 2 in there, so I get 16 times 2 plus pi, and the denominators multiply out to just 4 plus pi, plus pi over 8 times 8 squared over 4 plus pi, and that becomes 8. So we now have 64 over the square root of 4 plus pi minus, okay, let's distribute, minus 32 plus 16 pi over 4 plus pi plus 8 pi over the same denominator, and just one more line and we'll be done. 64 over the square root of 4 plus pi. Now we're taking away 16 pi's, and then we're adding back 8 pi's. So we're taking away 8 pi's, and we're also taking away 32, all over 4 plus pi. If you like, you can factor out an 8 from the whole problem. Factoring out 8 from there will give you 8 over the square root of 4 plus pi minus, if you factor out the 8, you'll have pi minus 4. And there it is. That is the max area. It's all algebra, folks. It is all algebra. Okay, let's do a couple of more problems, and then we'll end with a really nice one. One where you could show your teacher up. So suppose we want to find two positive numbers such that the product of the two numbers is 192, but you want the sum to be the min. There are many numbers that multiply out to 192, like 1 and 192, 2 and I guess it's 97, but I don't buy that. It must be 96, excuse me. And then 3 times 64, 4 times 48, 6 times 32, 8 times 24. there's many different numbers that multiply out to 192, like 12 and 16, yeah, and that might be the only one that the only ones I can think of, yeah. Okay, there might be a couple of others. 14, 11, yeah, those are probably the only 7. But so there's many ways of multiplying two numbers out to get 192. But I want the sum to be the least. Assuming that these are the right pairs, that sum is 193. The sum of those two numbers, 67, 52, 38, 32, and 28. Looks like 28 is the least sum. But that's not the way to do it. You want to use calculus. So, let x and y be their two numbers. Okay? So, x times y equals 192, and you want to minimize x plus y. You want to minimize that. So, let us give this a name. You want to minimize the sum x equal y. So, you have what you want to minimize, but there we go again. It has two unknowns. Well, from this equation, dividing both sides by y, you get that x equals that. So now, s is equal to 192 y to the minus 1 plus y. Now I can take the derivative. Y prime is, well, bring down the power, you get negative 192, make the new power 1 less, plus 1. Now, you want to set this equal to 0. So, this number that I circled must be 1, because negative 1 plus 1 is 0. So 192 over y squared must be 1. Immediately, you have a fraction that equals 1. You say that the numerator and denominator are equal to one another. So y is the square root of 192. Now, this makes me panic because y is supposed to be a perfect square. We're supposed to know the square root of that. Okay, so the instruction was supposed to be minimize x plus 3 times the other number. Okay, so this should have been 3y, and the derivative of that is 3. Minimize x plus 3y. Okay, sorry about that. So then, the only real problem we have is that this should be 3. Okay, because negative 3 plus 3 is 0. So 192 y to the negative 2 must be 3. Okay, so now you can interchange those two. You know, like 10 over 2 equals 5. If I interchange them, 5 over 2 equals 10. 14 divided by 7 is 2. If I interchange them, I get 14 over 2 is 7. If you ever ask 3 over x equal 2 to solve for x, please don't take more than 3 seconds to do that problem. Just interchange the 2 and the x. So y squared is 192 divided by 3, which is 64. Beautiful. So y is 8. Why don't I say plus or minus 8? Because they say that x and y are positive integers. Now, what is x? Well, right here, it says that x is 192 divided by 8. And 8 goes into 19 2 times with 3 left over, and 8 goes into 32 24 times. Those are the two numbers. So, that's the min sum. 8 and 24. Now, what I wrote on the right here was not correct. Because when I add them, I was like for this pair, those are the wrong sums. For that pair, I was supposed to do 1 plus 3 times 192. For that pair, I was supposed to do 2 plus 3 times 96, etc. Of course, then, if I have 1 and 192, I should also have 192 times 1. And that sum should be 192 plus 3 ones. And if you did that with all the 14 combinations, because why 14 combinations? Well, let's try to clean this up a little bit. You have those numbers, but now we're not just adding them. If you just add them, it doesn't matter which number you have first. But now, for example, we're only multiplying the second number. We're multiplying the second number by 3. So you also have to have 192 times 1, 96 times 2, 64 times 3. Since I forgot the answer, I'm going to keep doing this. 24 times 8 and 16 times 12. And it seemed that x is 24 and y is 8. It seems like this gave us the smallest sum. You're going to have 24 plus 3 eighths. The smallest sum is going to be 48. Now, if we do that, x is equal to x plus 3y's. We found that x was 24 and y was 8, so I tripled that, and yep, we do get that the min is 48. Okay. Now, we're going to do one more problem. It's a very interesting problem in that we can do this very easily. And I got my calculus professor actually quite upset with me about how I solved this problem on an exam. You have two telephone poles. So this is the ground, and you have two telephone poles. One is 10 feet tall, the other is 20 feet tall. And you want to run a wire from the top of one pole to the top of another pole. But you have to touch the ground. And wire costs money, so you want to minimize how much wire you use. So, for example, you can go down here and then up. Or you can go down to that point. You can go down to that point and then up. Or you can come way over here and then go up. Of course, if you want, you can go straight down and then up to that point. Or you can go all the way over to this point and go up. Okay, it's somewhat ridiculous to go out here and then go up. And the reason is, let's suppose this distance is the same as this distance. So if you just go here and then you go up, this is some distance. Now, if you go here and then you go up, this distance here is the same as this distance. The only thing is that the other half, this yellow piece, is much shorter than this piece here. So there's no point in going past there. So the question is, where do you go? Now, I'll show you the easy way of doing this. You have 10 feet, and then you have 20 feet. Now, you come to some point, whatever point it is, and then you go there. Now, if I draw this down here 20 feet, isn't it true that this distance is exactly the same as that distance? They're similar triangles. If this is 30 feet, well then this is 30 feet. And I guess I really didn't mean to pick that point. I think it's important that I pick another point. Suppose I pick this point, that point. And suppose this is 30 feet. Wouldn't this also be 30 feet? So now, let me see if I understand this. I want to minimize the distance from here to here. But that distance is the same as this distance plus that distance. That is, I want to minimize the distance from here to here. Ooh, I know that answer. I'm just going to draw a straight line. That is where I cross. That is where I cross. Okay, want to say that again. You come here and then you go there. But going on this portion, that's the same as reflecting it. If this is 20 feet, I'm going to make this also 20 feet. So this distance that I'm now drawing in blue, this distance here is the same as that distance. So I really want to minimizing that distance is nothing more than minimizing that distance. But minimizing that distance is just a straight line. Suppose that's 20 feet. It's just minimizing a straight line. Okay, so now let's do high school algebra to do this. Let us call this point right there the origin. So this point being 10 feet high, this point is at 0, 10. This point here is 20 feet high. And I guess I needed to give you one other piece. The distance between the two poles is 50. Sorry that I didn't give you that. Okay. You have to know the distance between the two poles. Now, this other pole on the right, it is 20 feet tall. Well, the x value will be 50 because it went over 50. The x value is 50. And the y value is going to be 20. This is 50, 20. But I don't really care about that point. I care about the reflected point. It's going to be 50, negative 20. So if I can find the equation of this line and then plug in y equals 0, I can find the x value. That's what I want to know. Along here, where do I put the wire to the ground before it comes up here? Okay, so we want to find the equation of this line. Well, we know 2 points. Let's find the slope. I subtract the y values. I subtract the x values. I get negative 30 over 50, which is negative 3/5. Okay, I now know the slope. And I'll use the point 0, 10. There's a 0 in it. So I'm coming to the left. So y is equal to mx plus b, but now we know m. So y is negative 3/5 x plus b. So I want to find b. Well, I know that when x is 0, well, I know b. That's the y-intercept. b is 10. Okay, that is the equation of the line. But I want to know the x value when y is 0. Okay, so 0 is equal to negative 3/5 x plus 10. Bring this over. 3/5 x is equal to 10. Multiply both sides by 5 over 3. That way the 5's cancel, the 3 cancels. You just get x. Multiply the other side by 5 over 3. And what's that? 16 and 2/3. Okay, that is, you should ground the wire. See if I have a better picture. Okay, so when it comes to doing this problem in real life, here is the ground, here is the 10-foot pole, here is the 20-foot pole, and here is 50 feet. From this point, you measure out 16 and 2/3 feet. Make believe that is 16 and 2/3 feet. If you anchor the wire right there, you'll save the company money. If you put it anywhere else, it'll cost more money. You'll need more feet of wire. Notice I didn't say how many feet of wire you need. But that's actually pretty easy. We won't do it, but that's really easy because the amount of feet that we are going to need is simply the distance between 0, 10 and 50, negative 20. The distance is the change in y squared minus the change in x squared. You know what? We have the change in y squared. We have the change in x squared. So the distance will be, no. We just have the change in x and the change in, we have the change in y, which is the numerator, and we have the change in x. So all we need to do is square them. You get negative 30 squared plus 50 squared, the square root. And negative 30 squared is 900 plus 2500 square root. This is 3400, which is the square root of 100 times the square root of 34. The square root of 100 is 10. The square root of 34, we don't know. We can't break it down any. So this is how many feet of fencing you need to use. That's the least amount of fencing you need. Now, let's do this using calculus. This is not going to be funny. This is not going to be funny at all. This is why I guess my teacher was somewhat pissed off at me. She's like, you knew I wanted you to use calculus. And I'm like, no, I didn't. You told me to solve the problem. Okay, so in any case, this is 50 feet. So we run it like this. This portion we'll call x, and that portion we'll call the rest, x minus 50. Okay, so I have two triangles, triangle 1, triangle 2. And I can find the area of each triangle. That's not a problem. I didn't mean to say that. I can find the lengths of each side. I can find the lengths of that side, and I can find the lengths of that side. So Pythagoras would say that length is the square root of x squared plus 10 squared. And Pythagoras would say the length of that is this squared, 50 minus x squared, plus 20 squared, which is 400. So the total distance is the square root of x squared plus 100 plus the square root of 50 minus x all squared plus 400. Now, you may say, finally, we have D, what we want to minimize in terms of one variable. Yeah, that's the only nice thing about this problem. Finding this derivative and setting it equal to 0 will not be the easiest chore. So this is that function to the half plus 50 minus x squared plus 400 to the half. So now let's find out d prime. So first we have our function to a power. Bring down the power, make the new power 1 less, and then multiply by the derivative of what's inside, which is 2x. Plus, you have a function to a power. Keep the function the same. Play the power game. Bring down the power, make the new power 1 less, then multiply by the derivative of what's inside. Well, it's a sum. The derivative of 400 is 0. So we have to find the derivative of 50 minus x squared. Oh, something to a power again? Yep. 50 minus x, bring down the power, make the new power 1 less. Don't forget to take the derivative of what's inside. Okay. Half of 2x, or half of 2 is x, is 1. So you just get x. And this piece, since this has a negative exponent, I'll put it in the bottom as square root. Plus, actually minus. It's minus because of that negative 1. Okay. Now, this half kills off that 2. So what we have left is the 50 minus x in the top, and this piece goes to the bottom as square root because we have negative half power. So it's 50 minus x squared plus 400. Okay. Now, this is d prime, and we want to set it equal to 0. Well, if this minus that is equal to 0, those two quantities are equal to one another. Okay, x over the square root of x squared plus 100 is equal to 50 minus x over the square root. I'm going to try really hard not to square 50 minus x. Okay, now I'm going to square both sides because I don't want square roots. So I get x squared over x squared plus 100. And then I have to square that 50 minus x. So I get 50 squared minus 100x plus x squared over just the denominator. But I just squared 50 minus x. I know what it is. It is 2500 minus 100x plus x squared plus 400. So that's going to become 2900. 2500 plus 400 is 2900. This is a nightmare compared to the other way. Now let us cross multiply. So you get x squared times that x squared times all of this. 2900 minus 100x plus x squared. And this is equal to this times this mess, which is 2500 minus 100x plus x squared. Okay, let's keep doing this. Well, that gives us 2900x squared minus 100x cubed plus x to the fourth. This gives us 2500x squared minus 100x cubed plus x to the fourth. And then this plus 2500 with two more zeros minus 100x with two more zeros plus 100x squared. Now, the good thing is a lot of things cancel out. There is the equal sign. This and this, they're exactly the same. Bye. This and this, exactly the same. Goodbye. And, okay. Now, if I bring these over to the other side, I'll just have 400. So I have 400x squared, and I'll bring everything else over, plus 10,000x. Oh, so I brought that over, plus the 100x squared. When I bring it over, it becomes minus 100. So I only have 300x squares on the left side. And that's dead. And then I bring over 250,000. Now, one of the reasons I don't, and this equals 0. One of the reasons I don't like putting in commas a lot of times is because they give me trouble in the end. I could remove in each one of these terms, I can remove 2 zeros. And it would look like a mess. Let me cross that out better. If I still had the comma in there. So we have 3x squared plus 100x minus 2500. Okay, oh, it's 3. So let's see if we can factor this. We have 3x times x. Now, whatever number I put here is going to be multiplied by 3x. And whatever number I put there is going to be multiplied by 1x. So now, how do I get negative 2500? You can have 50 and negative 50. Now, if I triple that number, I'll get 150. And if I just leave that number alone, I'll get 100. Ooh. So I'm going to triple the 50, and I'm going to take away 50. Let me just verify this, please. That looks right to me. And this equals 0. So either that's 0, which means 3x is 50, or x is 50 over 3, or that's 0, which means that x is negative 50. Now, we're going to reject that because when it came to the poles, I said that this distance was was 50. So x is 0 here, and x is 50 there, and we pick something in between. Negative 50 would be out here. So that looks like 50x, so let me just write reject. So I claim that x is 50 over 3, which is, I don't think, very good, because when I did it the other way, please don't tell me I erased it. When I did it the other way, bingo, we got 50 over 3. Okay, so we got the same answer, one using calculus and one using basic algebra. In my opinion, the calculus was a nightmare. Okay, so just for completeness, I'm into that. This is 50 over 3 feet, which is 16 2/3 feet. So we got the same answer, but the calculus was a lot harder. And I always tend to think, I'm not a mathematician, but I know mathematicians won't always agree with me. But I think that when you solve a problem, you should use a method that's the lowest level. And algebra is below calculus, so I think you should use algebra to do such a problem. And it's pretty neat that you don't need the calculus. Again, if you go to here and to here, going this distance is exactly the same as going the mirror image. Go down 50 feet and then go that way. This distance and that distance is the same. So sum 1 and sum 2, that's the same as adding sum 1 or distance. Let me call it distance. Don't know why I'm calling it sum. Adding distance 1 and distance 2, well, let me call that distance 2 prime. It's the same as adding distance 1 and distance 2 prime. Well, let me understand this. I want to go from here to here, and I want to go shortest distance. Oh, shortest distance between 2 points is a straight line. That is where you cross. And it turned out that that was 50 over 3. Okay, that's enough for this video. It's almost 2 hours long. I hope you learned some optimization problems.